students, welcome back. Now this video onward we will discuss the concept of circle. So let's start. Now student, let's deal with the basic part of the circle. I have taken one circle with center O. If I take any point on the circle, suppose I have taken point A, suppose here is my point B, here is my point C, here is my D. Then OA indicate the radius. Same way when I join OB, it is also radius, OC is radius, OD is also radius. So whenever we are dealing with this, all these radius are equal. When you concentrate on this one of the part, this is the sector. In that, this circular part is a part of the full circle, circumference only. This part is known as R. So there are 1, 2, 3, 4. Now 4 arcs are there, and what you have observed that all these 4 arcs together form a circle. When you are taking the protector, it consists of 180 degree. So when you take the other protector in the way, then it is also 180 degree. So together is 360. So sum of all these arcs together when form a circle, it is 360 degree. What does mean? Measure of arc. If I start with A, now my measure of arc AB plus measure of arc BC plus measure of arc CD plus measure of arc DA. Together they form a full circle. So their addition will be always 360 degree. This concept you have to always keep in mind. For example, if I say this arc is 100 degree, this is 120 degree, and this is suppose 80 degree. So how to find this arc? Now see, 100 plus 120 is 220, 220 plus 80 is 300. So when you subtract this 300 from the 360, so remaining is 60. So by using this concept, the fourth arc will be 60 degree. Now students, I have taken one circle with the center O. Now, if I take any line which touches the circle at a point, then that is known as the tangent. Suppose it touches at the point A, then it is known as tangent to the circle at A. And this A is known as the tangent point. Same way, if I take any point outside the circle, how many tangents we can draw, students? Just think. Yes. If I draw a tangent like this is one tangent. From the same point, second tangent. So what you have concluded? A point is on the circle, single point, then you can draw one tangent passing through that point. But if your point is outside the circle, you can draw two tangents. Now, further see, students, if I join this center and the tangent point, what you have observed? This is perpendicular to the tangent. So line joining the center and tangent point is always perpendicular to the tangent. That is our tangent theorem. So this you can always apply whenever the tangent is there. How you can apply? that line joining this center and the tangent point is always perpendicular to this tangent. Now see, in the circle, I have taken the center O. This is the line which I have divided, which intersect the circle at two distinct points. Then this line is known as secant. The part of the secant which lies inside the circle is known as chord. So chord is nothing but the part of secant itself, students. Now, you have done last year also in the 9th standard that when you draw a perpendicular from the center to the chord, then it bisects the chord. Which is the chord theorem you have done? Again I am repeating, what is that chord theorem? The perpendicular drawn from the center to the chord bisects the chord. So OP is my perpendicular to the chord. Then this AP and PB both are equal. If you go reverse, the line joining the center and the midpoint of the chord is always perpendicular. That is the reverse of chord theorem. Then it will be converse of chord theorem. Okay, so chord is nothing but not a separate anything. It's a part of the secant which lies inside the circle. Now students, two figures I have shown. In the first one, the circles with center P and Q touch externally at point A. So they touch externally. Now in the second figure, both the circles touch internally. So they are touching each other internally. So when you look at the figure, if I join these both the centers, and if R1 is my radius of first circle and R2 is the radius of second circle, then my distance between P and Q, that is the distance between both the centers of the circles which touch externally, then that will be equals to R1 plus R2. If I say this is 3.5 centimeter and this is 2 centimeter, then distance between their centers is 5.5 centimeter. But when you look at this figure, when you join the PA, then your PA full is R1, correct? The radius of the larger one, and the radius of this smaller one is R2. Then just see what will be the distance between their centers. Yes, the center, this distance between their centers, that is P and Q. R1 is the larger one. R1 minus R2. If I consider the same measurement, then 3.5 minus 2, then it will be 1.5 centimeter. So what you have concluded, student? If two circles touch externally, the distance between their center is the sum of both the radii. But if the circles touch each other internally, the distance between the center will be the difference between their radii. Thanks for watching this video, students. Hope you have understood whatever I explained in this video. Now, if you have any doubt, you can comment or mail. If you like the video, share and subscribe. Thank you.